So this is my lab report for Physics 2212 on our first lab called charge tapes. To introduce this lab, the purpose of this lab was to determine the sign and magnitude of the charge on the surface of the piece of tape, in this case tape B, treating it as a point charge. So for the experiment, prior to the experiment, I tried to see what the charge actually was on the tape, whether it was positive or negative. So I rubbed the pen, and using this diagram, this shows that it was attracted to the pen, and a pen has a negative charge when you do that. So it means that it must be a positive charge on the sticky side of the tape. And right here is just a picture of my setup. I didn't actually get a good picture of what happened in the experiment because I wasn't able to, but here's my setup for how I did it. And I ended up with something like this where the tapes repel each other. And that's my preview, is that tape A pushed up tape B. Some fundamental principles I used in this lab, that the force of gravity is equal to mass times acceleration of gravity in the y-hat direction, or the magnitude is just mg. The magnitude of the electric force on B by A is equal to 1 over 4 pi epsilon 0 k times the two charges over r squared. And we can make this more friendly to our experiment by just squaring the charge of B, because these charges are the same essentially, and d squared is just the distance between A and B here. And then the Newton's second law, so force is equal to mass times acceleration, in which acceleration is 0 in this experiment, meaning that the force of gravity is equal to the electric force, meaning that this tape B, once it's repelled, will float there because it's being balanced out by both of those forces. So here is an enlarged diagram of my experiment here. You can see we have the electric and gravitational force balancing each other out. I have the distance between them here, the tape length total between the bridge, and the tape width. So I calculated gravity first by taking the mass of tape B, multiplying it by the acceleration due to gravity. And then I also have the charge of tape B, which you can find if we manipulate this equation right here just for QB. So that's where I get this number here for the charge. And then the electron deficiency, if you just multiply that charge times how many electrons there are per coulomb, this is what you get. And then as for calculating how many atoms per electron lost I had, it's a process of finding the area of tape, finding the total amount of atoms by dividing the tape area and the atom area. And then the atoms per electron, it's just what I have here, total atoms divided by electron deficiency. The assumptions for this experiment when I performed it was that we treat tape as a point charge, and that there's no other forces other than the two forces, gravity and electric force, acting on the tape. This is the glow script coding model that I used to try and compare my experiment results. This is the output here on the left. On the right here is what I had for my code. Up here we have constants, 1 over 4 pi epsilon 0, the tape mass, length, etc. And then we use those constants to do some calculations, finding the force of gravity, the charge of the tape, in which I output that charge of the tape here, and then all of those atom calculations we talked about before, and then I print that there. And then down here, I use the instructions from Lab 0 to help me form this visual right here with the basically two tapes, the force of gravity, or the force of gravity and the electric force. Comparing my experiment results to the glow script results, they're pretty close, so there's not much error, but there are some potential sources of error. For example, other forces, like we said in assumptions, we assume there's no other forces, but there might have been other forces like air resistance that were not accounted for. Also, the dimensions, I could have measured them incorrectly, the width and length and mass, stuff like that. And thirdly, I could have mishandled the sticky side of the tape. I tried my best not to, but accidents happen, and this could have affected the experiment as well. Some final discussion questions. The first one, what if electrons had positive charge and protons had negative charge? I believe this wouldn't change anything about the attraction that I see in this experiment, because regardless of their charge, both tapes are going to have the same charge, and same charge will always repel each other. So we would see the same thing out of the tapes repelling each other. And then why is it important to handle the charged tapes as little as possible? Because when you touch the tape, it gives electrons and charge to your hand, and so that disrupts the charge balance that would otherwise be distributed to the tape in an actual experiment.